Wind energy has grown at a surprising rate both in the number of turbines and their capacity. More than ever before, there is a requirement for standardized testing and certification of remanufactured transmissions. The Achilles heel of wind turbines is the gearing system. The high step-up ratio is a challenge for any gear designer. In order to advance tomorrow's testing technology, these factors have to be considered. Wind energy is variable. Fluctuating conditions cannot be emulated by discrete loading devices, and testing should emulate real-world conditions. When a turbine fails, there are large costs associated with removing the turbine from the field and into a testing facility. If an inadequately tested transmission prematurely fails, the revenue lost is significant, not only due to the downtime, but from the cost of a repeated removal and replacement. 3 methods of testing exist today. Static testing is the simplest and least informative method. It does not allow the transmission to rotate. It does not provide any valuable information about the condition or the life cycle of the transmission, and it does not allow the running in of new gears and bearings. Discrete testing. It is the current industry standard. It allows the transmissions to rotate at a fixed torque load. It provides valuable information about the condition and life cycle of the transmission. The problem with discrete testing is that it cannot emulate real-world conditions. Full spectrum testing will become the industry standard. It allows the transmissions to rotate at loads and speeds that perfectly emulate field conditions. It provides valuable information about the condition and the life cycle of the transmission in a real-world scenario. Full spectrum testing is required to improve reliability of the remanufactured transmission, which will result in a significant reduction in maintenance costs. This is a typical 100:1 ratio step-up transmission. The challenge was to build a rugged and reliable full-spectrum testing device that is able to run economically. The enhanced 4-square testbed is Area 51 solution. This device is a mechanically recirculating power setup. The only energy required to operate this enhanced 4-square is the amount needed to overcome the inefficiencies of the drivetrain, typically around 15%. This energy is supplied by the pony motor that regulates the RPM of the test procedure. The FM box is the heart of the enhanced 4-square. It is a mechanically actuated device that allows real-time modulation of torque loading. The actuated device is simplified here in the animation. In real terms, the actual device uses an electromechanical actuator. As can be seen, the torque load can be matched to simulate any conceivable test procedure, from the running in of a new transmission to buffeting winds. All this can be done without any reconfiguration of the test setup. The enhanced 4-square can economically perform long-duration testing, unlike comparable electrical systems, and the environmental footprint is vastly reduced. Components of the enhanced 4-square are readily available and inexpensive to maintain. Due to the simplicity of the design, the maintenance staff and operators require minimal technical training. Today's current climate demands clean, efficient, economical solutions for the estimated growth of the wind turbine industry. The estimated growth for 2015 would bring Canada's installed wind energy capacity to more than 7,000 megawatts. Area 51 Machine Design has over 15 years' experience with high-performance transmissions. This includes planetary drives of over 300,000 foot-pounds capacity, providing you with experience and reliability you can depend on. Area 51, passionate machine design.